everyone, this is Jake with GSSI, and I'm here today to show you how to use the PaveScan MDM, which stands for Mix Design Module. Folks use the PaveScan MDM system in order to create a mix calibration which correlates air void content of a sample or a field core with the dielectric of the field sample or core itself. All right, so when we have that, we can see real-time density out in the field, or we can export out our information as density instead of just dielectric for the PaveScan RDM. One thing to note about the MDM are just the parts of the pieces that come with the MDM. So we have the concentrator box here in the back. Just like with the PaveScan RDM, we have to plug in our controller, which is this Panasonic G1 tablet, which runs our software, as well as our sensor, which we have here, which is measuring our samples. We also have the calibration kit, which is made up of this bracket that goes over the sensor itself. We have two blocks of Delrin, which are the same exact dimensions. We have a metal plate as well, and then we have a verification cylinder. Okay, we use the verification cylinder just to verify that the sensor is reading accurately. Every verification cylinder has a dielectric on it, so when you measure it using the PaveScan MDM, you can confirm that your sensors are reading very accurately. Okay, so let's get into it. I have my sample here that I'm going to be measuring. This is a gyratory sample that we have. We already have the volumetrics that have been run on this sample, so we know that it's 5.01 air void content. So that's worth noting. In order to get a mixed calibration, you have to have both the measured dielectric of this, which we will go over, but you also have to have the measured air void content of the sample. So that either needs to happen before you measure it or after you measure it using the MDM. If you're using it after the air voids are calculated, you need to make sure that this core is extremely dry, as we know that water is an enemy to GPR technology. Notice too, I have the sensor nowhere near other things that might be higher than the sensor. That way we can make sure that the sensor is not interfering with those other objects, or I should say these other objects aren't interfering with the sensor and aren't factoring into the readings that we're getting. Okay. So to begin here, we've got the software. Looks the same as the RDM software. To begin the process, I'm just going to hit collect. It's going to tell me that the sensor is detected. I'm going to hit next. I can select an existing project if I have one created already, or I can hit new project. Okay. I can select my project group, then give my project name. Project name would probably be the name of your mix that you have, where it's from, the plant name, something like that. Everyone sort of has their own convention. Okay, so I'm just going to name the new project name Sample 1. I'm going to hit save. When I hit save, it opens up the ability to take new measurements. All these other categories here are optional fields that I can fill in. I don't have to fill them in now. I can always come back in and fill them later if I want to fill them in at all. I'm going to go to new measurement. From here, I can name the file. So I can just name it, in this case, I'm just going to name it Sample 1 after my first sample. The sample thickness. Now we should measure the sample here for its height using calipers, okay, for the most accurate measurements possible. In this case, what I would want to do is I would want to measure this sample at 90 degrees, right? So if you imagine 4 evenly placed quadrants here, I'd want to measure at each one of those parts, okay? What I'd want to do is write down each one of the values that I get. Then I would add those values up, divide by 4, and I would have the average height of this sample, okay? I already know that the sample's height is 115.15 millimeters as the average height of it. I also already know the air void content for this. It's at 5.01. Okay. We'll go over rotation angle in a second when the time comes. Lastly, we have these other optional fields that we can fill in either now or later if we wish. I'm going to advance to collect, show you what collection looks like. Collection using the MDM is really simple and easy. We're going to use our calibration kit for each one of these steps. First, for background, I'm going to place one Delrin block on top of the sensor. It should fit in there nice and snug. This block of Delrin is never going to leave here during the calibration process. There's always going to be one block of Delrin right here up against the sensor. For this first measurement, I'm going to place the second block of Delrin right on top of it. I'm going to make sure it's lined up nice and even. And then on the software, I'm going to hit background. It's going to take just a second. And now step one, background, is completed. It's now asking in the software for the metal plate. I'm going to remove that second block of Delrin. I'm going to leave the first block of Delrin. I'm going to place the metal plate snug into the confines of that Delrin block. I'm going to hit metal plate. Excellent. That step's complete. Now I'm actually going to take my sample. Okay. I'm going to place it on top of the sensor. Now just as a heads up, ultimately what I'm going to be doing, I'm going to be measuring this sample 3 separate times at 0 degrees, 120 degrees, and 240 degrees. So what that means is I'm going to just choose a spot. I can even use a little bit of like chalk if I wanted to mark out the thirds of this. Okay? I'm going to consider this to be my 0 point. When I rotate it, I'm going to rotate it to this point over here, which is going to be my 120, and then this point over here, which is going to be my 240 degree. So here, I have it placed on the block in the confines of the Delrin. I'm going to hit surface on the UI. Okay. And then I'm going to place the metal plate on top. Hit that. Now the steps are complete. It's going to give me a bulk dielectric down bottom. It says 4.851. All right. For now, I'm not going to go over that reading. That's just the reading that we're getting. I'm going to hit save. Okay. Now again, I'm going to measure this sample using that same exact process 2 more times for a total of 3 times per sample. So first what I'm going to do is I'm going to change my rotation angle now for the next reading to 120, and then I'm going to change the angle here of this to my 120 degree angle. I'm going to remove it. I'm going to change the name of this second reading. I'm just going to call it sample 120. Okay. Now I'm going to repeat that same process. I'm going to place Delrin block on top. Background. Place the metal plate. Then I'm going to place my sample at 120 degrees rotation. Then I'm going to place the metal plate on top of the surface, make sure that plate is snug on top of my sample. It's going to provide me with a second reading, 4.867. I'm going to hit save. Now I'm going to repeat this one last time. Now I'm going to measure this sample at 240 degrees. Okay. So I'm going to rotate my sample to my 240 degree point. I'm going to remove it. In order to prepare for collection, place my background block on top. I'm going to go to collect. I'm going to measure my background block. And measure my metal plate. And you can imagine now, as you're getting into a workflow, this process goes very quickly. lastly, my metal plate. Okay. It's reading 4.852. Hit save. Now at this point, for this demonstration, that's going to be the end of me measuring these samples. Most likely you would have more samples that you would be using in order to create your correlation curve, so you would have more points along that curve to use. In this case, I'm just going to use this one sample measured 3 times. So now I've gone back to project info. Now it says measurements down here, right? Before, new measurements was grayed out, only new measurements was active, because we didn't have any measurements to select. We didn't have any that were saved. So if I click measurements, it's now going to give me the measurements I just created. And we can see now here the bulk dielectrics that were collected for each side, right? So they're all about 0.01 away from one another, right? So from here, I can click on File Properties, and I can see the file properties. If I put down any optional notes in those fields, I can see them. But what I'm going to do is I'm just going to go to Generate Mix Calibration. Okay. I can name this mix calibration something, right? If I wanted to, I could name it any details about the mix whatsoever. Okay. I'm just going to hit Save. And then I'm going to go to Calculate for Measurement. So now I have each one of my readings here, okay? I have the percent void content, and since I'm using the same sample 3 times, my percent voids should not have changed. It's going to stay the same. It's only the dielectrics that have very, very ever so slightly changed. So from here, what I'm going to do is I'm going to hit Calculate GMM dielectric. Let's say I measured 3 more samples. I'd want to make sure that they were included in the calculations. If I got any really wonky far out outlier readings from one of the samples or from just one of the measurements and I couldn't account for why, I might decide to not include that in the measurements. Instead, I'm going to include all 3 of these measurements. Okay. So I'm going to hit Calc GMM dielectric. GMM dielectric 5.239, standard deviation of 0.01. Perfect. Going to hit Save, which is going to advance me to this screen here, where now I have my mixed calibration file name, my GMM dielectric listed as well as 5.239. Okay. So now I have created a calibration file. I've created a calibration that is linking the percent void, how much air is in a sample, to the dielectric of the sample itself. So now what I can do is I can take that value, 5.239, and if I have something like a PaveScan, I can create a mixed calibration now on the PaveScan. All I have to do is go into the PaveScan, into mixed calibration, create a file name, I could call it whatever I want, and then I only have to enter in the GMM dielectric value, 5.239. And now when I'm going to collect, right, on a mat that has that same exact mix, it's going to be calibrated to that, so I can be collecting data and see in real time density numbers. That's a powerful thing to be using out in the field, right? If this is something that I'm collecting for the state, right, as part of a specification, then I can be seeing real time numbers out in the field. Or what I could do is when I export this information out, I can attach this mixed calibration to the file set it belongs with, right? And then those files would go along with that mixed calibration associated. Okay. That's it for the MDM. It's as simple as that. Collection with the MDM is really as simple as taking a background reading, metal plate, then a sample, and then a sample with a metal plate. And then I just repeat those steps 2 more times, adjusting for the angle each time. If you have any questions, let me know, please. I'd be happy to help you out. And from the folks here at JSSI, we appreciate working with you. Thank you for your time.